Our next example, we're really going to use the chain rule to take the derivative of this. So y equals cosine squared x. So first thing is rewrite this as cosine x squared. So when we rewrite it like that, hopefully you see that this would be a chain rule problem. So to take the derivative, you're going to take your exponent and pull it out front. You keep your insides the same. You subtract 1 from your exponent, so it's just to the 1. And then you take the derivative of what's inside your parentheses, which the derivative of cosine is negative sine of x. So your final answer is negative 2 cosine x sine x. Next one, y equals the square root of cosine of x. So first, you want to rewrite this as this is cosine x, all raised to the 1/2 power. So chain rule, take your exponent, pull it out front, keep your insides the same, subtract 1 from your exponent, 1/2 minus 1 is negative 1/2. Take the derivative of what's inside your parentheses, which is negative sine of x. So I have a negative sine of x in my numerator. I have a 2 in my denominator, and then I need to send the cosine x to the 1/2 to the denominator in order to make that exponent positive. Getting a little bit more complicated. F of t is equal to sine cubed of 4t. So first you want to rewrite this as sine of 4t, all of that cubed. So now I'm going to do the chain rule. I'm going to take my exponent, pull it out front, keep my insides the same, subtract 1 from my exponent to make it 2. And then now I need to take the derivative of what's inside my parentheses. So remember, this is not sine of x, or not sine of t, it's sine of 4t. So remember, this is the thing with the u's. So the derivative of sine is cosine. You keep the 4t the same. And then you have to multiply by the derivative of 4t, which is 4. So your final answer, you're going to need to multiply the 3 and the 4 together to get 12. And you can either leave this as sine of 4t squared, or you can write it sine squared 4t, and then cosine 4t. Next one, y is equal to 2 cosine cubed of 5x. So first we're going to rewrite it, bring that exponent outside. This is 2 times cosine of 5x cubed. I'm going to use a chain rule, so I'm going to take my exponent and pull it out front. 2 times 3 is 6. I'm going to keep the insides the same. Don't touch them. I'm going to subtract 1 from my exponent. So now I'm going to take the derivative of cosine of 5x. Remember, it's 5x, not just x, so I'm going to have to do this stuff with the u's. The derivative of cosine is negative sine. I keep the 5x the same. Then I have to multiply by the derivative of 5x, which is 5. So I'm going to take my 5 and my 6 to make negative 30. So the 5, the 6, and the negative. Cosine squared 5x, sine of 5x. And our last example, 3 tangent squared of 3x. So again, Actually, pause your video. Try this one on your own. Let me make this a U-try problem. Pause your video, try this on your own. Okay, first you gotta rewrite it. So it's 3 times tangent of 3x minus 1 squared. So I'm going to take the exponent, pull it out front. I'm doing the chain rule. 2 times 3 is 6. I'm keeping my insides the same. Keeping my exponent, subtracting 1 from my exponent, so it's 1. Now I have to take the derivative of what's inside the parentheses. The derivative of tangent is secant squared. Remember, I keep the u the same. But then I have to take the derivative of my u, which the derivative of 3x minus 1 is just 3. So the last thing I have to do is 3 and 6 make 18. Secant squared, 3x minus 1, tangent, 3x minus 1. If you had said 18 tangent 3x minus 1 secant squared 3x minus 1, that would have been fine as well. I don't care about the order. Alright.